Good morning, everyone. I hope all of you are doing fine. Today, we are going to take a little bit helicopter view and go a little up. We were going into semiconductor physics in diodes and different things and what is happening in semiconductor. Now, we are going to just zoom out a little bit and look at that if we see different functionalities which are coming, right? There are a lot of functionalities which are performed on a chip or any AI hardware or any hardware which we are talking about, right? We see sometimes that they are coming or originating from different avatars of or various avatars of your MOSFET, right? So that is what we are going to talk about today, so that you can see that one simple, I would not say simple, but one device with different variations can result in so many different functionalities, right? And that is what is the power why we are very concerned about understanding the physics and what is happening in MOSFETs and all of that. And then there is some background understanding of devices, which is what uh, where your PN junctions and all this come from, or you need to have that understanding to understand or appreciate MOSFET, what is happening, right? So today our goal is, okay, if we have, you were talking about, let's say there are different kind of functionalities, let's say even in a digital system like a computer, where you have a computing unit, you said, then there is something which is a memory, and there is probably a control unit, right? um, and all of these are working in some fashion together, so that you have, what you get is, let's say, whatever you are want to do a particular task of, let's say, summing two numbers or whatever that task is, you get that done within this computer. That is the main thing. Now the question is, okay, if that is the different functionalities one need, one functionality which we have been seeing in a from our MOSFET was this switch, right? That it can act as a switch. This is the control terminal which controls the flow of electrons or the current within this transistor. And that is how I can switch on and switch off whenever it is making, or it is, let's say, whenever I put it in a circuit. Very simply, we saw that this could be very effective in making memories. And this is, if you have not seen that video, do check out that video where we talked about the leakage and then even the memory, um, like DRAM block. And this is the key DRAM cell which we see, which is, you have a switch, right? And with the switch, you have your capacitor, which stores that state or stores one or zero, what we say, right? So this is the basic. So that is where you see this is okay, not, I mean, this is okay, we have seen, right? There's nothing new. So what is the avatar then you are talking about? Are you talking about that it can be used as switch in different circuits? No, that is not what we are talking about in avatar. Avatar means that we are talking about different manifestation of this, right? This is a use of that switch. So but the functionalities of a switch, right? That is the thing. So now the question is, what other forms or other manifestation it can have? So one we can see, and which you would have probably seen when you talk about amplifiers, right? And we have seen that this can be used as an amplifier, a very basic circuit which we start with. And if you want to study amplifier, is this circuit, right? Where you apply an input at certain point, which is your small signal which you are acquiring from physical phenomena like your sensors or your microphone or whatever, and there you want a large signal here, right? Or large means like amplified signal. That is what the basic understanding. And to do that, we need to then understand first MOSFET, in which region and everything this would happen. Because if we apply just to a bare MOSFET, it can act as a switch. Switch means if you apply a signal, let's say, for example, let's just take an example. You are applying, let's say, 100 millivolt signal at the input, right? And this transistor, we know this comes with a threshold voltage. For example, we have been discussing this threshold voltage. If this VDD is around 5 volt, which we are looking at, this threshold voltage could be, let's say, 1 volt, for example. So now if you are applying 100 millivolt, even if it is a AC signal, which is varying between 0 to 100 millivolt, right? You see this transistor is not going to budge, because you see that if you apply VI directly, which is 0 to 100 millivolt, right? You see that your output, because what would be your output? First of all, if we can see the condition of the MOSFET, MOSFET would be on or off? Is off. And why? Because you see that your VI or mod of VI, let's say the magnitude max, is lesser than your VTH. So that means your transistor itself is not turning on if you are directly putting a signal which you are acquiring from any physical phenomena or very weak signals. So then what is the point of then amplifying? Because if it is off, then you see there is no current flowing. That means IDS is zero, right? Whatever the IDS is flowing. So IDS, when it is zero, then you see if there is no current flowing, that means there is no drop across the resistor. If there is no drop across the resistor, then V out what you would get is VDD. Oh my God, then it is just giving me a not get kind of functionality, that I apply a very small signal, it gives me a high signal. So it's a very nice not get, right? But not not an amplifier, right? It does not work as an amplifier. So then you see, okay, what do I need to do in this circuit if I want to make it as an amplifier? Because I want to amplify a signal. And that is where you see that this VI cannot be directly applied to this. And what we need to do is we need to put this VI. That means first we have to make the transistor on. If we want amplification, what do we need? You need this transistor to be on, right? Otherwise, if it is off, it gives you V out VDD, which is not useful. So then if you wanted to make it on, that means your VGS has to be greater than VTH, right? And when you see that your VI, which you are acquiring, but the limitation, what is the limitation? That your mod VI VX is much smaller than VTH. Then you are again, oh, my whole goal of using an amplifier was to amplify this signal. If to make the transistor on itself, if I have to amplify the voltage, then what is the use of this, right? This circuit. Then you figure out, okay, then if this is not the signal which can do, can I apply in certain way that DC voltage, which I can apply externally, right? How I'm giving battery here, like 5 volt, I can apply this voltage externally, and on top of this signal, right? On top of this signal, I superimpose whatever signal I'm getting in the series of this. So this is my VI, and this is what I will call a bias voltage. What is the meaning of bias voltage? Is you have to make your transistor on, right? And that is what you see, that this bias voltage, the job of this is to bring your MOSFET into an operating region, because it was just watching, it was just off. So you now bring it into the game where you say, okay, you are now in operating region where you have chance to amplify, right? Where it has chance to amplify. At least give it as a chance. So for giving it as a chance, you have to make it on, and that is what you amplify. That is what you do with this bias voltage. Okay, so that is what typically you are taught. I think if you have seen transistor, yeah, it can act as a switch and it can act as an amplifier, right? That is what typical functionalities which we see. But is it all it is that more than that, right? And then you can say, oh, if that is the all, what can else can we do with this? Because you are telling me there are different avatars, these are just two avatars I have seen. What else do we have that the functionality? Then you will see that if, let's say, this transistor we saw, right, and we saw this as in, for example, if this was a digital voltage, which what we are applying, right, 1 or 0, you see that you are getting a 0 or 1 at the output, right? So it's behaving like a NOT gate, which is like a switch. Basically, it is behaving like a switch here, and which is giving this functionality. Can I use this functionality which I get of NOT gate to store the data? Because what we see here, whenever input changes, right? This is your input, this is your output. When IP changes, output would change with it, right? But what we want is, let's say we want a memory. Memory means that it can store. And until it goes beyond certain, so that means what I want is a memory element, for example, right? Where whenever I don't want to write, so when I want to write, it writes, right? When I want to read, then it gives me stored data, right? So that means even in reading, I'm applying a signal, right? Inside, there is a certain voltages I'm applying, which should not change the state, but it gives me the stored state. Now the question is, how do I store the state? One way or one example you saw is this DRAM cell, right? Where you saw, okay, that it is basically what it is doing is it's storing this on a capacitor. Okay, good. But you are telling me, okay, if let's say I don't want to use a capacitor, because I would say capacitors are bulky, it would take too much area to fabricate that, right? For example. But on my chip, I want to make these devices, and how do I make? That is the question you are asking. So then you see very interesting property that if you were to, let's say I'm just representing this circuit which we saw as a NOT gate, right? That if I have these elements where I'm applying an input and you're getting an output, but what you are saying is that I don't want that. I want my output to be stored, right? So that means it does have some kind of multi or bistability, right? Stability means that whenever, so let's say what is happening as of now, whenever you are changing input in a landscape, it would seem like when you are changing an input, your output is changing, right? Because your input is changing, your output is changing. What we are saying is that in a bistable state means that to go from this state to, let's say this is state 1, this is state 2. So from going from one state to another state, it does take some amount of voltage, right? And if it does not provide in the input that voltage, it does not go from one state to another state. That means rather than just being a input to output, can I store this into a bistable state? That is the question you are asking. So that means there should be a way that this has to hold data. And when it has to hold data, that means output has to talk to input also. It's not just the input is talking to output. Output also has to say that, no, dude, whatever you are trying to change at me, I want to remain in the read state because I want to store that state. So don't keep changing me until you become so strong that you want to write on me. So that means for this part, to communicate this part is what we do with a circuit, which is what we know as the basic latch circuit. So this is a basic latch, which you see can be made with 2 transistors if we have used resistor like this. Or if we are using a CMOS, which we will talk in another video, you could use 4 transistors to make this simple circuit, right? Where what is happening is that you want to write, let's say this is 1, this is 0 is written. Now you go back to 0, it would give you 1. Now if there is an input change which is happening, which wants to change to the, let's say this to 1, right? This is what input wants to change. So this is increasing. So initially it is 1, so that means it is going to 0, and this wants to increase to 1. That is what the goal is. If even the input is changing, you see, if the input is not strong enough to make that change, this loop or this feedback system is going to keep that 1 to 1. because it is saying no, 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 you don't have to go and make the input or output 1 unless you have enough. That is the threshold voltage of your MOSFET, that you have passed that state that you have to make it 1. But what is the beauty in this is, even if you remove anything, let's say from the input, your output state will remain in this latch, because now it is a part of the feedback, right? That is what is the simple memory element you can see one can build with this MOSFET. Okay, so now we saw switch, DRAM, we saw amplifier, we saw NOT gate, we saw latch, which is a memory. Is there more than that? Obviously, I would not disappoint. There is lot more than that, and I think we cannot talk about all of them today. But I'll talk about one final case, which is also which you would have heard. There's a flash or flash disk or flash memory, right? So now, what is the memory? Because this, what you are doing is or the basic block of what we call is a SRAM cell, right? Not SRAM cell, but let's say this is the building block of SRAM cell, right? Building block of SRAM cell. SRAM means is another kind of memory, which is um, also known as cache, which you see level 1, level 2, level 3. All of those cache which you see on a computer specification are typically made with this SRAM cell, right? So at least level 1, right? Definitely. So then this means that you see that this is a very small or uh, building block of this kind of cache is basically your transistor, this latch block which we saw. DRAM, which we have already saw, which is what you famously know as the RAM, right? How much RAM do you want? So something like 8 GB and all those you are talking about, 16 GB is the range. There is the range of cache. We are talking still somewhere in MBs, right? So that means you can already see if the limitation of SRAM cell on the, if you were to make a GB, you would probably occupy, I don't know how many chips, right? So that is the key, that it is not very efficient, though it is very fast, but it is not very efficient in the area. And that is why this is a limited quantity. Then you come with another thing which is slower. It's okay, but it can give you a large storage, right? Which is what we mean by large storage. Means we are talking somewhere in like 512 GB or 1 TB, right? That is the range we are talking about. Now the question is, what is this flash disk, or what is the avatar of transistor I'm going to see? So, tada! Now I have to draw a physical structure of the MOSFET first to start with, which is what we have seen in another video. So you can check out that video if you have not seen. Whereas this is our basic MOSFET, right? MO oxide, your metal, your semiconductor. When we apply a voltage here, we see the current is flowing or not flowing. That is what we have seen in your MOSFET, right? This is your VG or control signal. So this acts as a very good switch, which is your MOSFET structure. It can also act as an amplifier in this configuration which we saw, right? But what is that we are going to transform this, because this cannot store. Storing means there should be, even if the supplies goes off, there should be that charge is somewhere stored. What happens here is when the VDS goes to 0, right? You see your current goes to 0, right? There is nothing, all the charge, everything has gone back, like what generation recombination we have seen before. Everything died down until you bring in that charge again, right? So the charge which you bring in again, probably by applying VGS, then you apply VGS, you see charge, and then you can probably apply lower VDS to see. But as soon as the VGS and VDS are gone, you see that, okay, things are not very pretty in the sense of storing the state, right? So then what can we do if we want to store the state? So that means, is there any way that if I cannot store this in the semiconductor, because semiconductor will respond to the VG, right? Is there a way that I can store it into some other layer? And that is where this whole idea of floating gate comes from, which is called floating. It's floating in between, floating gate. There is an oxide here, and then there is a bigger oxide, and then there is metal, right? This is, and we can talk about this in a separate video if you have interest to understand, or we will talk about somewhere sometime. But the what is floating gate doing is that when you apply a very, let's say you are now in the state of writing. So when you are writing, then you apply high VG. Now what happens when you apply high VG, that actually your floating gate, which is what I would say as the FG, right? This is your floating gate, right? Oh, sorry, I wanted to make a highlight. Yes, this one, I think. So your floating gate, basically, what would it have? It would store the charge. Store the charge. How does it happen? All of that we will see in the operation video of this operation video of a flash cell. But what happens that it stores the charge, and whenever you remove VG, let's say VG is 0, FG still retains the charge. It does not go anywhere. That is the beauty about it. And that is how you can see that you can store the data here because you are storing that charge into your floating gate. Interesting, right? So a lot of different avatars we have seen today. There are more than that. I mean, it's just, how do you say it? It's just scratching the ice, right? There's much more than that, and we are going to see in different videos those things, and maybe we'll see another video of the different avatars or more avatars of that, just to talk about first what other avatars exist, right? So as of now, what we have seen, going from switch amplifier to memory cells, and like this beautiful memory cell which we know as the flash, which is what you find typically in your SSD in a different form. The structure may look different these days, but it is what you find in your SSDs, right, or your solid state drives. So that is what, or your flash, that means that your USB sticks, right? So that is what you see is the workhorse of those technologies. So now with that, I would end here this video, and I wish you all happy learning. Keep growing. As many questions you have, please don't fear to ask, because all of this, whatever this initiative, the idea of this again is to make you excited about semiconductors. And also we want you to post, interact, and even if you want to work on some projects, we can suggest some projects which you can start on your own wherever you are sitting in the world. Does not matter. Okay, if you are, only thing which we need is the interest, and you have the drive to feel very okay that, oh yeah, this is something which I love so much that I want to know more and more, right? So that is what I would like to share, and I want to be if I can help in any way, I am there. I am all in. So you just ask that question, you contact me whatever way it is possible. Okay, thank you, and we continue our journey. We will continue our journey, and hope you will benefit, all of you, from some of this, whatever we are talking about. Thank you.